Hi everyone, welcome to Telugu One Academy. I am Ankit Reddy. So as part of upcoming UPSC Prelims examination, T1 Academy is conducting marathon sessions. So as part of that marathon sessions, I am going to deal with geography. Okay, coming to my educational background, I have done my masters in geography and currently pursuing PhD in Usman University. So I have around 7 years of teaching experience, teaching for both UPSC and TGPSC aspirants. So I am going to deal with geography and environment for this marathon session batch. Okay, so today we'll deal with one of the important topic for UPSC examinations, that is seasons. Okay, so first we'll try to cover the topic and then we'll try to solve PYQs. Okay, this is the area where UPSC frequently frame questions from, that is the seasons of the world. Okay, so first of all, starting with the basics, you know that Earth is a planet which is spherical in shape. We call it as spherical, but actual shape is called geoid. The shape of the Earth is geoid, which is flat at poles and bulge at the sides. Okay, flat at poles and bulge at the sides, especially the bulge is maximum at the equator. Okay, so what is equator? Equator is nothing but a 0 degree latitude. 0 degree latitude is called as equator. 0 degree latitude is called as equator. So this equator divides Earth into two equal hemispheres, that is the northern hemisphere and the southern hemisphere. Okay, so what is the shape of the Earth? Shape of the Earth is geoid. The shape of the Earth is geoid, which means flat at poles and bulge at the equator. Okay, so because of this nature of the Earth, the sun rays directly fall on equator and tropics. Okay, and as you move to the higher latitudes, the sun rays will be oblique or slanting. Okay, so because of the bulge of the Earth at the center and the flat at the poles, the sunlight, you know that sun is a source of light and heat for us. So the sunlight directly fall on equators and the tropic, and as you move to the higher latitudes, the sun rays is slanting. Now you may get a doubt. So what is the doubt? Why? What would be the impact of this thing? So when the sun rays directly fall in a particular place, then that region receives high amount of insolation, that is heat, high amount of heat here in this region. And as you move to the higher latitudes, the temperature decreases. That is the reason why the poles, the polar regions are seen in North Pole and South Pole, right? So these places are extremely cold, because though these regions receive sunlight, it is not direct. That means when sunlight is not direct, that means the heat will not be that intense. Heat maximum can be seen in the tropics. Okay, so small information about latitudes. Latitudes are nothing but the lines drawn from west to east, imaginary lines drawn on the globe from west to east. Okay, so the line drawn from west to east and which divides Earth into two equal hemispheres is equator. So 0 degree latitude divides the Earth into two equal hemisphere. Okay, likewise there are other latitudes as well. So they are 90 in the north and 90 in the south. So these are imaginary lines, not visible. So the next important latitude among the 90 in the north and 70 in the south is the 23rd of degree north latitude. It is called as Tropic of Cancer. Okay, and then same this time 23.5 degree south latitude is called Tropic of Capricorn, Tropic of Capricorn. Okay. Then similarly we have one more latitude called 66.5 degree latitude, that is called Arctic Circle. And then in south also you have one more latitude, that is 66.5 south latitude, is called Antarctic Circle. Okay. Then 90 degree south pole, 90 degree north pole. Okay. So these are the important latitudes. So what are latitudes? Latitudes are imaginary lines drawn from west to east. Okay. So 0 degree latitude, that is equator, divide the earth into two equal hemisphere, northern hemisphere and southern hemisphere. Okay. So there are 90 latitudes in the north and 90 in the south. So most important one are the 23.5 degree north, that is Tropic of Cancer, and 23.5 degree south, Tropic of Capricorn, and 66.5 degree of Arctic Circle and 66.5 degree Antarctic Circle. And the north you have North Pole and South Pole. Okay. So one important thing what you have to remember is that the sun rays are direct at the equator and tropics. At least once in a year the direct rays of the sun fall between tropics. Tropics is nothing but the Tropic of Cancer and Tropic of Capricorn. This entire region is called tropic and this region is called equator. So this region receives direct rays. So that is the reason why the tropical countries experience high temperatures, and they are most of the period in the year they are warm. They are warm. And once you move to the higher latitudes at the Arctic Circle, okay, polar region, the Antarctic Circle and South Polar region, here temperatures are low. Temperatures are low, winters are extreme. Why? Because the direct rays of the sun, the sun's direct rays do not fall here, instead they are slanting, or you can say oblique. Okay. The angle of this thing will decrease when you move to the higher latitudes. So remember, lower latitudes 0 degrees, 23.5 degrees, these regions always have high temperatures because the direct rays of the sun fall in this region. Concentration is more, and when we move to the polar regions, the sun rays fall in this region, but they are slanting, so the concentration is less, so temperatures are low here. Okay. So I hope you understand this basic concept. Okay. Right. Now one more important thing is that just now we have discussed that the earth shape is geoid. Okay. And we have discussed that the important latitude, this equator, which divides 0 degree latitude, which divides the earth into two equal hemispheres, that is northern hemisphere and southern hemisphere. Okay. Now coming to the axis of the earth. What is axis? Axis is nothing but the line, imaginary line drawn from north pole to south pole from the center of the earth. Imaginary line drawn from north to south from center of the earth. Okay. So this axis of the earth is not straight. The axis of the earth is not straight, instead it is tilted. It is slightly tilted. How much is this tilted? The axis is tilted, and that the tilt of the earth is 23.5 degree. The earth tilt is 23.5 degree. That is why in the latitudes 23.5 degree Tropic of Cancer and Capricorn are important. 66 degree Arctic and Antarctic Circle are important. Okay. Right. So the tilt of the earth is 23.5. Okay. The movement of the earth on its own axis is called rotation. The movement of the earth on its own axis is called rotation, and the movement of the earth around the sun, the movement of the earth around the sun in an orbit is called as revolution. The movement of the earth on its own axis is called rotation, and the movement of the earth around the sun is called revolution. Okay. So rotation is responsible for day and night. The phase of the earth which is facing the sun will be experiencing day, and the other side will be experiencing night. And when the earth comes here in the rotation period, this side will be facing the sun and opposite side will be facing the darkness. So, the phenomena of day and night is because of Earth's rotation, its movement of its axis. And what is revolution? Revolution is nothing but movement of the Earth around the sun is called revolution. Okay. Now, this revolution and tilt of the Earth, this revolution and tilt of the Earth is responsible for change in seasons. Change in seasons. How? We will totally look into that. Okay. So, the tilt and the revolution of the Earth is responsible for the seasons. Now, we will look into that, how this happens. The Earth has two motions, as I told you, that is the rotation of the Earth and revolution of the Earth. Movement of the Earth on its own axis is called rotation, and the movement of the Earth around the sun is called revolution. So, to complete one revolution, Earth takes 365 and half days, 365 and half days to complete one revolution. So, that is why after 365 and half days. So, here in a year we consider just 365 days. So, after 4 years, this 1/4 will become 1 day, right. So, 4 1/4 in a year becomes 1 day. So, that is a year. Leap year has one extra day in the calendar. Leap year has one extra day in the calendar. Anyways, okay. So, 365 days. Normal year consists of 365, leap year consists of the 365 days. The shape of the Earth's orbit is elliptical and shape of the Earth is geoid. Okay. The shape of the Earth is geoid, which is flat at poles and bulge at the equator, whereas you know that the Earth revolves around the sun, it is called revolution, and this path, this is called orbit. The path around which the Earth revolves around the sun is called orbit, and it is elliptical in shape. Elliptical in shape. Okay. Whereas the shape of the Earth is geoid. Okay. So, the seasons are nothing but changing. You see, in summer season generally nights are long, days are long, nights are short. In winters nights are long, days are short. So, this is nothing but changing in the seasons. Okay. So, how this changing in the season occur? 2 points, that is the tilt of the Earth and the revolution of the Earth around the sun. Okay. So, among the student community there is a strong wrong notion that when during the Earth revolution period, when the Earth come close to the sun, it will be summer, and when the Earth is far away from the sun, that will be winter. No, that is absolutely wrong. It is not about the place of the Earth. Yes, sometimes the Earth come close to the sun, it is around 1. So, generally the average distance between sun and the Earth is around 150 million kilometer. So, the farthest and shortest distance is around 147.5 million kilometers, that is the shortest distance between Earth and the sun, and around 152 million kilometers the distance between the sun and the Earth is maximum. Okay. But that is not the reason. The reason for the seasons is the revolution of the Earth and also tilt of the Earth. How season to season the vertical rays of the sun change and how it impacts season, we will look now in detail. We will look into that matter in detail now. So, just now we have discussed that you can see the vertical rays of the sun, because of the bulgeness of the equator, it is direct and it is oblique at the poles, that means slanting. Okay. So, solar energy maximum received at the equator and tropics and minimum at the poles because of the slanting rays of the sun, right. So, on March 21st, the vertical rays of the sun fall on equator. Okay. So, this is sun, let us take sun, this is position of Earth here. Okay. So, here on March 21st, the vertical rays of the sun fall on equator, at the equator. So, whenever the vertical rays of the sun fall on the equator, the Earth experience equal day and night throughout the Earth. Okay. So on March 21st, where the vertical rays of the sun is falling on equator because of its earth revolution and tilt. So it is falling on equator. So you can see the direct 90 degrees rays is falling at the equator, and rest of the sun you can see that the inclination of the sun is decreasing. So there will be 12 hours day, 12 hours night throughout the earth, no change. And since it's March 21st is a spring month, it is called spring equinox. It is called spring equinox. Next, on June 21st, you know, May, June months are summer months in northern hemisphere, right? Why we experience summer in May and June? The reason is the vertical rays of the sun fall directly on Tropic of Cancer. Earlier in March it was in equator, and slightly they shifted, the vertical rays shifted towards the Tropic of Cancer because of tilt of the earth and revolution of the earth. Now the vertical rays shifted to Tropic of Cancer in the month of June. Date is June 21st. Okay, and this day is called summer solstice. This day is called summer solstice. Now let us see what happens to the length of the day and night variation on June 21st. So you know that this is, you can see this is the tilt of the earth. This is the tilt of the earth is not straight like this, it is tilted 23.5 degree. So on June 21st, the Tropic of Cancer will be facing the sun directly here. So as a result, the direct rays of the sun fall in this region, and this region is warm. Now what happens during this period? You can see that at the equator we have 12 hours of time, but now since the vertical rays of the sun is falling in northern hemisphere, especially on Tropic of Cancer directly, so you can see that length of the day night is increasing. Okay, and at polar region you can see 24 hours sunlight. You can see 24 hours sunlight here in the north, 24 hours sunlight. Okay, and in the south, that is below the equator, you can see that the length of the day is decreasing. The length of the day is decreasing, and at the south pole it is almost 0. So 0 sunlight will be there on June 21st. So on June 21st, the vertical rays of the sun fall on Tropic of Cancer, that is in the northern hemisphere. So as a result, as you move to the higher latitudes in the northern hemisphere, the length of the day increases, and at the poles you can see that even in midnight, even in Arctic region and midnight region, and Arctic and the north region, you can see the midnight sun. 24 hours you can see the sun on June 21st. That means sun will not set below the horizon. Sun will be in the sky. It will not set below the horizon. You can see the sun 24 hours. So that's why Norway, Sweden is called land of midnight sun. Even in midnight you can see the sun. And in the opposite hemisphere you can see darkness, complete darkness. When this phenomenon happens? On June 21st. Why this is happening? Because of the tilt of the earth and rotation of the, as a revolution of the earth. Right. Once again, on September 23rd, the vertical rays of the sun fall on equator, on the equator. So you all know, so September is a month of autumn, so that's why it's called autumn equinox. Equinox, on what happens on equinox? Equal day and night, equal day and night, 12 hours. See, everywhere there is 12 hours, 12 hours day. So March 21st and September 23rd are equinox. March 21st is called spring equinox or vernal equinox. Vertical rays of the sun fall on equator, and on September 23rd also the vertical rays of the sun fall on the equator. This time it is autumn month, that's why it's called autumn equinox. 12 hours day, 12 hours night throughout the world, no change. Then December 23rd. Now December 23rd is called winter solstice because the vertical rays of the sun fall on Tropic of Capricorn now. So let's say if Tropic of Cancer passes through India, you all know this. So the vertical rays is falling far away from us, not at the equator but down south near Tropic of Capricorn. So here it will be summer, here it will be summer because of direct rays, and northern hemisphere will be experiencing winter. Okay. So in the northern hemisphere it is winter solstice. Now what happens in the winter solstice? exactly reversal of June 21st will happen. Now the vertical rays, the earth, because of its revolution, the southern hemisphere is facing the sun now. Southern hemisphere is facing the sun. That's why these direct rays of the sun fall on Tropic of Capricorn. Tropic of Capricorn. So as a result, what happens? The angle of inclination decreases from that point towards the poles in the northern hemisphere. So because of this, you can see 24 hours darkness in the north pole. So here it should be south pole. So in north pole 24 hours darkness and 24 hours light in the south pole. On June 21st, what we have seen in northern hemisphere, there will be, that is in the poles, you can see 24 hours darkness and 24 hours light, 24 hours day. You can see the 24 hours sun on June 21st in northern hemisphere. Sun will not set below the horizon. You can see in the sky. And exact reversal will happen on December 23rd. 24 hours light can be seen in south pole and 24 hours darkness can be seen in north pole. Okay, this is what happens on December 23rd. So I hope you have understood this reason, right? So what happens on March 21st? The vertical rays of the sun fall on equator. Since it is called spring, equator is March is a spring month, it is called spring equinox or vernal equinox. So here on March 21st, the center part of the earth will be facing the sun. So that's why direct rays is falling on equator. And slowly what happens on June 21st? The earth will change its position, right, in its path of revolution. So here, since the earth's northern hemisphere is facing the sun, the direct rays of the sun fall on Tropic of Cancer. As a result, you can see 24 hours day, that means light seen on sun in the northern hemisphere, and here 0 hours of sunlight. Then once again the earth will change its position according to season. In September 23rd, on September 23rd or 21st, the vertical rays will once again fall on equator because the central part is facing the sun now. So same 12 hours day, 12 hours night. And once on December 23rd or 22nd, the earth comes in this position, and result the southern hemisphere will be facing the sun. So direct rays will is falling on Tropic of Capricorn. As a result, you can see 24 hours darkness in northern hemisphere and 24 hours light in the southern hemisphere. Always remember, if, to avoid confusion, if vertical rays of the sun is falling on Tropic of Cancer, that means 24 hours light, direct rays light, opposite side darkness. So on December 23rd, what happens? The direct rays of the sun fall on southern hemisphere. So southern hemisphere you will see 24 hours light and the opposite side 24 darkness. Only these two are important because March, September are same, equator, but since it is in the spring, it is called spring equinox, March 21st, and September 23rd, it is called autumn equinox. Okay, and always remember, whatever the season that is there in the northern hemisphere, the exact season will be there in the opposite sphere. If northern hemisphere it is summer, in southern hemisphere it will be winter. In southern hemisphere if it is summer, in northern hemisphere it will be winter. Okay, why? Because all depends on vertical rays. Wherever the vertical rays of the sun fall, that region will be experiencing summer, and opposite latitude in the southern hemisphere will be facing winter. Okay, right. I hope this concept is clear. Now let us solve some questions here. Okay, so pause the video and try to understand here. Now this is equator, this is Tropic of Capricorn, this is Tropic of Cancer. Now the earth is tilted, the northern hemisphere is tilted toward the sunlight. Now vertical rays is falling on Tropic of Cancer. Which day it is will happen? When the earth tilted, the northern hemisphere is tilted toward the sun. So direct rays is falling on Tropic of Cancer. Now which day it will be? It will be June 21st. So as a result, 24 hours light here and 24 hours dark in the southern hemisphere, right? Then now you can see this is equator, this is Cancer, this is Capricorn. So here the south hemisphere is facing toward the sun, so direct rays is falling on Tropic of Capricorn. So this happens on December 23rd or 22nd. So vertical rays falls on the Tropic of Capricorn. So this part will be experiencing summer, and December is winter in the northern hemisphere. Okay, so you can see 24 hours darkness at the pole, and you can see 24 hours light in the southern pole. Okay, I hope it is clear. If you are in doubt, please once again watch that video. So let us solve some questions here related to this topic. Previous UPSC questions, favorite topic, right? So what we will do is, please pause the video, try to solve the question. Okay, I will continuation, I will give explanation. So on June 21st, the sun. The question is about June 21st. Now, when they are asking about June 21st, you are in mind you should get the clarity that on June 21st, the vertical rays of the sun fall on Tropic of Cancer. That means, so since the vertical rays fall in the northern hemisphere, 24 hours light in the Arctic region and 24 hours dark night in the Antarctic region. Okay. Right. Now you can directly answer this question now, knowing this content. 2019 prelims question. On June 21st, the sun. So on June 21st, the sun rays directly falling on Tropic of Cancer. So 24 hours light here and 24 hours dark in the southern hemisphere. So on June 21st, the sun does not set below the horizon at the Arctic Circle. Okay, right? Does not set below the horizon in Antarctic Circle. Wrong, because near the northern hemisphere only you can see 24 hours light here. So A is the correct answer, but even then you can also look into CD options and you can eliminate. Shines vertically overhead of noon on equator. No, sun rays are not vertical on the equator on June 21st. It is on Tropic of Cancer. So answer wrong. Shines vertically overhead at Tropic of Capricorn. This is wrong. This happens on December 23rd. This happens on March 21st and this September. This happens on December. So two are absolutely wrong. 1 and 2. So does not set below the horizon of Arctic Circle. Yes, sun will not set below the horizon. You can see 24 hours sun on June 21st. So land of midnight sun, Norway, Finland, Sweden region. Sun does not set below the horizon in Antarctic Circle on this is December 23rd. So option B is also wrong. So answer A is correct. Does not set below the horizon. Now next question, same related UPSC 2019, 2 years gap, once again in 2022. In the northern hemisphere, the longest day of the year normally occurs on. Longest day in the occurs on. So simply you know that March and September equal day and night. That's why it's called equinox. Okay. So in the month of summer solstice, that is on June 21st, the vertical rays of the sun fall on Tropic of Cancer. Okay. Then on December 23rd, vertical rays will fall on Tropic of Capricorn. Okay. Now the question is, the northern hemisphere, the longest day in the year is seen in. Generally, when do you see the longest? Pause and try to answer. The longest day is in the month of June. So you can delete July. Okay. First half of the month. So it is 21st. So first half means in top 15 days. Next half means next 15 days in the month. So it is June 21st. So answer will be second half of the month of the June. Longest day is seen. Simple. Next, 2013 same area tropic prelims question. Variations in the length of the daytime and night time from the season to seasons are due to. So season to season, what is happening? There is change in the length of the day and night. Change in the day and night is because of rotation of the earth. Here the length of the day is changing, the length of the night is changing. This is because of seasonal. So the seasons are because why they are occurring. What is the reason for that? You know all that. Earth rotation on its axis. Rotation, you have day and night, but not change in the length of day and night. So option 1 is wrong. Latitudinal position of this place, not correct. Revolution of the earth on the tilted axis is correct. Yes. Revolution plus tilted axis. Sir, you might get a doubt, sir. Sir, revolution only, because of revolution only the direct rays is changing. No. If earth axis was straight, it was not tilted. Always Equator would receive direct sun rays, okay. But because there is tilt, the vertical rays shift between Tropic of Cancer, Capricorn and sometimes on equator. So, the answer is revolution of the earth and tilted axis, okay, is the correct answer. So, this is about the seasons or revolution of the earth, where they repeatedly ask questions, okay. Now, we will move on to another topic, that is latitudes and longitudes and how they are useful to us. Latitudes and longitudes and how they are useful to us. So, you know that the latitudes are imaginary lines drawn from west to east and they are parallel to each other, they do not meet. Okay. 0 degree equator divides the earth into two equal hemispheres, you all know this, and there are 90 latitudes in the north and 90 in the south. Most important ones are Tropic of Cancer, what is the number? 23.5 degree north, Arctic 66.5 degree north, Tropic of Capricorn 23.5 degree south, Arctic 23.5 degree, sorry 66.5 degree south. Okay. Now you might get a doubt, sir, why latitudes are always measured in angles, degree, why we are saying it is angles? Because simple thing, this is center of the earth. Suppose if you are standing here, the angle you are making with the center of the earth is 45. So, latitudes are nothing but, why we measure? Because it is an angular distance from the point of the earth to center of the earth. So, that is why we measured in angles. So, if you are standing here, you are making 90 degree angle with the center. If you are standing here, you are making 0 degree angle with the center. So, it is an angular distance. Latitudes or longitude, both are the angular distance. Okay. So, what is the definition? Latitude is an angular distance of a position on the earth's surface measured in degrees from the center of the earth, from center of the earth to place point on the earth. Okay. So, they are 90 in the north and 90 in the south. Now, how they help us? So, these latitudes help us to understand the heat zones on the earth. Just now we discussed that the vertical rays of the sun fall on equator in the month of March and September. The direct rays of the sun fall on June 21st in Tropic of Cancer, and December 23rd the vertical rays of the sun fall on Tropic of Capricorn. It should be Capricorn here, Capricorn. So, the vertical rays of the sun keep on shifting between tropics, okay. So, that is why it is an hot zone, it is a hot zone, or it is also called as torrid zone, okay. So, at least once in a year the vertical rays of the sun will fall in the tropics directly. And if you go beyond tropics, from Tropic of Cancer to the Arctic Circle in the north, Tropic of Capricorn to Antarctic Circle in the south, here these regions receive sunlight, but not direct, slanting. They receive large amount of light, but intensity is low because of the angle of sun rays. So, when you move to the north, in the temperate regions, temperatures are moderate, that means summers are mild, winters are somewhat little extreme as you move to the polar. So, moderate climate can be seen in temperate region. So, European countries, all this comes under temperate region maximum. Now, from 66.5 degree north to north pole, 66.5 degree south to south pole, this zone is called freezed zone, because the the sun rays are slanting, okay. You see sun, but the intensity of the sun's heat is less. So, because of this region, the north pole and south pole are polar region, they are completely covered with ice, glaciers, okay. This is how latitudes are helpful. So, as you move from equator to poles, temperature, what happens temperature? It decreases because of the angle of inclination of the sun, it decreases as you move to the north pole or south pole. I hope it is clear, okay. Then longitude. Longitudes are in general we say longitudes are nothing but the lines drawn north to south of the globe. See, both latitudes and longitudes are imaginary lines, they do not exist in reality. Okay. So, north to south. So, 0 degree longitude, there are 180 longitudes in the east and 180 longitudes in the west. So, they are 360, longitudes are 360, latitudes are 180, 90 in the north, 90 in the south, along with the equator 181. So, here it is double, 180 in the west, 180 in the east. So, longitudes are also is an angular distance, we measured it in angles. So, angular distance measured in the degrees along the equator east to west of the prime meridian. So, 1 degree, 2 degree, 3 degree, 180 degree. So, from center of the 0 degree longitude to the other longitude, it is an angular distance. So, longitude is an angular distance. So, unlike equator, there is no option other than equator to divide the earth into two equal hemispheres. Equator can divide the into two hemispheres. No other latitude can do that. But in case of longitude, any of the two opposite longitudes, 0 and the opposite of that side, can divide the earth into two equal hemispheres. So, in order to avoid confusion, the longitude which is passing through the Greenwich, a longitude that is passing through Greenwich in London is considered as the 0 degree longitude. 0 degree longitude. The longitudes which are towards east are denoted with the letter E and west are denoted with W. So, India is located in the eastern hemisphere. So, always the longitudes we need to denote with E. Okay. Now, what is the help of understanding this longitudes? What is the help of understanding this longitudes? Longitudes help us to understand or study the time zones of the world. Time zones of the world. How? We will detailedly discuss now. So, before that, small simple calculation is important for us. So, you know, earth is a rotating body, okay. It takes 24 hours to complete one rotation. That means, if earth is starting from this point and to reach once again this point, it takes 24 hours of time. That means, earth is covering 360 degrees, right, from, let us say if it is starting from 0 degrees and once again it is coming at this 0 degree point for 24 hours, okay. That means, earth covers 360 longitudes in how many hours? 24 hours, okay. That means, 180 degrees in how many hours? 12 hours, 90 degrees in 6 hours, 45 degrees in 3 hours, okay. 15 degrees in 1 hour, 15 degrees in 1 hour, okay. 15 degrees in 1 hour, okay. That means 15 degrees in 60 minutes, okay. So, 1 degree in 4 minutes. So, earth take in order to move from 1 degree to other degree, it takes 4 minutes, it takes 4 minutes, and to complete 360 degrees, cover 360 degrees, it takes 24 hours. Simple max with class question, okay. So, time zones. So, world has many time zones. So, each and every part of the world calculate time based on the 0 degree longitude, that is Greenwich, okay. So, the places which are located towards the east of Greenwich are always ahead in time, they are always ahead in time, and the places which are located towards the west of 0 degree longitudes are always behind in time, Why? Because you all know that sun rises in the east, okay. So, first sun rises in this part like New Zealand, Australia, Papua New Guinea, China, Southeast Asian countries, India, okay, Central Asian countries, Africa, Europe, the Greenland, the Canada, USA, Alaska. So, these is the sun will rise in this place. So this always eastern part will be ahead in time because first sun rises here and moves to the western part of the world. So remember, east ahead in time, W, that means western side behind in time, because the sunrise first takes place in the eastern part of the world. So whenever you calculate the time of the world, okay, whenever you consider India, you have to add time to Greenwich latitude, and when you are calculating the time of the western part of the world, you have to subtract, reduce, because sunrise will first take place and then come to this part. Okay, right, well and good. Now moving to our topic. So you know the 360 longitudes, we have 360 longitudes on the earth, imaginary 360 longitudes. So for each degree, if you have a separate time zone, each separate time zone, yes, there will be 4 minutes difference of each longitude, but it creates chaos in the countries like India. You cannot have 30, see, because the longitudinal extent of India, it is, you can see, it is from 67 to around 97. So almost there is 30 degrees difference between the both longitudes. It is around 68 here and it is 97. So 68, 97, almost 30 degrees difference. So for each degree, if you have different time zones, you will have a problem. So that's why we have chosen a midway for Indian Standard Time, that is here 68, right? So if you add 68 plus 15, you get 83, and if you subtract 15 from 97, you get 82. So that's why we have taken 82.5 east longitude is as the Indian Standard Time, IST. Getting my point? So 68 to 97 degrees. So central point, if you add 15 degrees, 62, you get 63. If you subtract 15 from 97, you get 82. So 82, 83, in between they have chosen 82.5 east, very important, 82.5 east is the Indian Standard Time. Indian Standard Time. Okay, always remember, once again, now think that 82.5, that is Indian Standard Time, and somewhere here, let us say 0 degree GMT, Greenwich Mean Time, Greenwich Mean Time. So now answer it to yourself that the Indian Standard Time, will it be ahead of GMT or behind? The answer is the Indian time is always ahead of GMT, because first sunrise take place here and then in the European countries. So that's why Indian Standard Time is always ahead of the Greenwich Mean Time. How much? So if the Greenwich latitude number, longitude number is 0, Indian Standard IST time is 82.5. Okay, so if you 82.5 into 4, for each degree 4 minutes, no? So Earth take 330 minutes to cover from this place to this place. Earth take 330 minutes. That means if you divide it by 60, you get 5.5 hours. Okay, so after crossing India to reach 0 degree longitude area, Earth takes 5.5 hours of time. So that means, so Indian time will be always 5.5 hours ahead of GMT, because from here to here there is 5.5 hour difference. From here in Earth to move from this place to this place, it takes 5.5 hours time. So that means if it is 10 AM in GMT, 10 AM in GMT, what will the time in India? Simple, 10 AM plus 5.5 hours. So what will be the answer? 11:30, 12:30, 1:30, 2:30, 3:30. 3:30 PM will be the time. Okay. Similarly, if it is 12 noon in GMT, what will be the time in India? 12 plus 5.5 hours. What will the answer? 1:30, 2:30, 3:30, 4:30, 5:30. Okay, 6 hours. 12 noon, that is 5.5 hours is added. So 1:30, 2:30, 3:30, 4:30, 5:30. 5:30 will be the time in India. 5 hours ahead. If it is 3 p.m. so here it will be 5 hours ahead, 8:30 p.m. I hope you are able to follow the concept here. Okay, always remember GMT time is equal to IST plus 5 hours time. Okay, let's say if it is 2 p.m. then plus 4, that means 3:30, 4:30, 5:30, 6:30, 7:30. 7:30 will be the time in India, 7:30 p.m. Okay, I hope it is clear. So IST is always ahead of 5 hours time of GMT. Now try to answer this question, pause it and try to answer this question. Determine the local time of Thimphu, Bhutan, located at 90 degrees east longitude when the time at Greenwich is. Okay. So, it's saying that the Greenwich 0 degree longitude is 12 noon. So, what will the time at 90 degree east at Thimphu? So, it is always ahead in time. So, 90 into 4, 90 into 4, okay, 360. That means alone 6 hours of time, 6 hours of time. So, if it is 12, it will be 6 p.m. ahead in time. So, it is p.m. Simple. Okay. Right, now answer this question. If it is 10 a.m. at the prime meridian, 0 degree longitude, what will the time in London? What will the time in London? Simple. IST is equal to GMT plus 5.5 hours. So, GMT time is 10. So, you have to add 5.5 hours of time. Okay. So, 11:30, 12:30, 1:30, 2:30, 3:30, 3:30 hours of time. 3:30 will be the time. Okay, simple. Rest of the places you need to know the light. Okay, and there is one more concept associated with this topic, that is international dateline. International dateline. So, you have 0 degree longitude, right, exactly opposite to the globe. This is 0 degree longitude, exactly opposite to that you have international dateline. So, first thing you can notice that international dateline is zigzag. International dateline is zigzag, it is not straight. Why it is zigzag? Because to avoid small islands. So, what happens if you cross international dateline, which is in the Pacific Ocean, international dateline, if you cross the international dateline, there will be change in your day, change in your daytime. So, that is why it is called international dateline. For example, this is international dateline. If you are moving from west to east of international dateline, because this eastern part of world will be ahead in time, US these kind of will be ahead in time. So, if a person is taking flight from New Zealand and moving to US, he will gain a day, because there is 24 hours of day. So, we gain, we means we are, if we are together we gain. So, when you are traveling west to east crossing international dateline, you will gain, remember. And reversal, if you are traveling from east to west, if you are traveling from east to west, you will lose a day, you will lose a day. International dateline, if you cross from east to west, you will lose a day. Remember, west to east, we are traveling from west to east of international dateline, you will gain, and east to west you will lose. Okay. So, this is about the international dateline. International dateline is zigzag, it is passing through Pacific Ocean, you have a Bering Strait and other. So, once you cross this, there will be change in day, okay, then the change in day. So, international dateline passes through the Pacific Ocean, imaginary line like longitudes and latitude, the time difference either side of this day is 24 hours. So, the date changes as soon as one crosses the line. Okay. So, there are many islands in here region. So, instead of, so if a small island, there is in between of the small island this international dateline passes, it will create problems. So that is why this zigzag, this international light line is zigzag. So when you are traveling from west to east, when you are traveling from west to east, you will gain a day along if you travel from east to west, you will lose a day, because this part will always be ahead in time. So if you are ahead in time and when you reach here, time won't be much different here. But when this is behind in time and you are going towards the region where you are ahead in time, so creating a problem. So we gain, remember, code to remember. Okay. So that's about the seasons of the earth, latitudes and longitudes. So both latitudes and longitudes help us to understand the location of a place, the location of the place. So latitudes, longitudes, so the meeting point will help us to understand the location of the place. This is called coordinates. So if when you search for a place in the Google map, it will show that it is 14 degrees north, 78 degrees east. So like it will show a map, so nothing but it is a coordinate. So latitudes help us, individually help us to understand the heat zones, longitude help us to identify the time zones. Both latitudes and longitude help us to know about the location of the place, geographical coordinates. So these are helpful in your GPS for Indian system like Navi and IRNS. Interior of the earth, interior structure of the earth. Okay. So just like how you peel an onion, when you peel an onion you get layer by layer, right? Similarly, earth also has 3 layers, okay, namely the crust, mantle and core. The crust, mantle and core. So earth interior has these 3 layers. So what you see on the earth's surface is crust actually. Beneath that you have mantle and then you have core. Okay. So how we are able to know about the interior of the earth? See, human beings, man is able to travel up to the thousands of kilometers, millions of kilometers in the space, thousands and hundreds of kilometers in the space, but is not able to travel on its own earth, beneath the earth's surface. Okay. So hardly human beings can travel up to 4 to 5 kilometers beneath the earth's surface. Beyond that you cannot travel, because as you go into the interior of the earth, temperature and pressure increases. Temperature increases. So we have limited sources to know about the interior of the earth. So what are the sources to know about the interior of the earth? So we have direct and indirect sources. Direct and indirect sources to know about the interior of the earth. So what are the direct sources? First we look into the direct sources which to know about the interior of the earth. So basically the most easy type of the source to know about the interior of the earth is the surface rocks. So on the earth's surface you find different type of rocks, and by studying them you can understand about the interior of the earth, especially about the crust you get more information. Then mining. Mining, you know that you 1 to 2 kilometers beneath the earth's surface for the extracting the minerals. Okay. So by this process we also know about the interior of the earth. So through mining and drilling operations we can observe the earth. However, you cannot go deep, up to 5 to 6 kilometers we can do that. Okay. And then with the operations like deep ocean drilling, with deep ocean drilling, that drilling the oceans, as the oceans are the lowest points on the earth's surface. So by drilling projects we are able to know about the interior of the earth. However, the deepest drill at Kola is up to 12 kilometers. So these kind of drilling activities also help us to know about the direct sources of the sun. And then interior of the earth. Then we have the volcanic eruptions. You know that the lava comes from the beneath the earth's surface and comes out. So that means the material which is coming from beneath, if you study, you will also get an idea that about the what is there beneath the earth's surface. Okay. So these are the direct sources to know about the interior of the, what are they? The surface rocks that are available, the mining activities, the deep ocean drilling projects and the volcanic eruption. Okay. All this will help us to know about the direct sources of the sun. Now indirect sources, right? Meteors. So what are meteors? Meteors are nothing but they are the remnants of planetary formation. Okay, so when this remnants or the debris of this solar system, when they enter into the earth atmosphere, they start burning. Okay, they start burning, and few parts may reach the earth surface, and by studying these meteors also we can understand about the earth, because the same material, the planets and same material, they might have formed from the same material. So meteors are a great source of help to know about the interior of the earth, because they are also part of the planets. Then gravitation. So everywhere on the earth surface gravity is not same. You can see there is change in gravity at certain places, but that means if you are close to the center of the earth, gravity will be more, and you are away from the center of the earth and then little distance from the center of the earth, you can see the change in the gravitation. So by this we can also understand about the interior of the earth. And then the magnetic field. So the rocks on the earth crust have magnetic field, right? Few rocks like iron, this portion have. So magnetic surveys provide information about the distribution of magnetic materials in the crustal portion. Okay, then the most important thing is the seismic activity. Seismic activity is most important thing to know about the interior of the earth, because the earthquakes wave generate beneath the earth surface, we call them as body waves. Initially earthquake waves generate in the interior of the earth, we call body waves, and once these body waves touch the surface, they are called surface waves. So when the earthquake occurs, these body waves travel in the entire body, and by observing the characteristics of these waves, body waves can be divided into the P waves and secondary waves, primary waves and secondary waves, primary waves and secondary waves. So these primary and secondary waves have different properties. For example, P waves, the primary waves of an earthquake, can travel through solid, liquid and gases, all medium, whereas S waves, the secondary waves, can only travel through the solids, it cannot travel through the liquids. So by understanding this nature, P waves also, they move in different speed when they move in solid, liquids and gases. So P waves and S waves of the body waves help us to know the interior of the earth. That means wherever the P waves velocity is changing, that means it is changing from solid to liquid. Okay, wherever the S waves are not going in the interior of the earth, that means that part is liquid in state. So by this we are able to understand the interior of the earth. Okay, seismic activity. So these are the direct and indirect sources to know about the interior. However, these sources, either it may be direct like the volcanic activity, the surface rock, deposition, drilling on mining, or the indirect sources like the magnetic field, the gravity and the meteors or the seismic activity. These give information about the interior of the earth, as we cannot go deep into the earth. Okay, so these sources help us to know about the interior of the earth, but however there is a large scope of doing research. What we know is not even 1 to 2% of the interior of the earth, right? So by understanding these things, we are able to draw a conclusion that by understanding this, the first layer of the earth surface is called crust. And then you have up to 2900, from crust to 2900 kilometers, you have a layer called mantle, and below that up to 6370 kilometers, 6370 kilometers deep, you have core. So it is the radius of the earth, 6370 kilometers is the radius of the earth. So first layer crust, mantle and core. So each layer has different characteristics. Okay, and the matter also change, some are in liquid in state, some are in solid in state, semi-liquid in state. Okay, so their chemical properties also change, the density, temperature also same. So based on their metal composition, they can be divided into crust, mantle and core. Okay, now let us study deep into these topics. So first part that what you see on the earth surface is crust. Okay, it is brittle in nature, just like your chickpea, Brittle in nature means easily it can break. Easily it can break. This is crust, it can break. So the thickness of crust, if you look at here, so basically what are oceans? Oceans are depressions, nothing but land, ocean. So wherever the depression, all the rainwater, rivers water go there and form oceans. Wherever there is elevations, you can find continents, right? So the thickness of crust obviously will be, the thickness of the crust will always be in the oceanic crust. Oceanic crust is always thin and continental crust is always thick. Continental crust is always thick and the oceanic crust is always thin, because basically oceans are nothing but depressions where water is accumulated. Okay, so the oceanic crust is thin and continental crust is thick. But when it comes to density, density of the oceanic crust is more. Okay, and density of the continental crust is less. Density is more in oceanic crust and less in continental crust. But when it comes to thickness, ocean crust is thin and the continental crust is thick. Okay, and it is brittle in nature. So as I told you, the oceanic crust is denser and compared to the continental crust, and whereas the oceanic crust is around 5 kilometers, that is thin, and continental crust sometime it may go to 30 to 70 kilometers if there is mountainous region. Okay, and mainly crust majorly consists of two minerals, that is Cl, that is silica and aluminium. The crust is majorly components of silica and aluminum, the crust. Okay, so what points we have covered here to crust? Crust, when compared to the crust, mantle and core, crust is the thinner layer. Within crust, you can see that oceanic crust is thin and continental crust is thick. Okay, and when it comes to density, continental crust is denser when compared to the continental crust. Okay, and crust is brittle in nature, that is each can easily break. So hardly the crust extends up to 100 kilometers. Okay, and since due to accessibility and all, we know we have good information about the crust when compared to other one, because it is immediately below the earth surface. Okay, CMA, Cl and this thing. Then we have mantle. The next layer is mantle. The mantle extends from the crust boundary to the 2900 kilometers. The boundary line between crust and mantle is called Moho discontinuity. So the boundary line between crust and mantle is called Moho discontinuity, and from here the mantle extends up to 2900 kilometer. Okay, crust hardly extends up to 5 to 10 kilometers. It is thin in the oceanic crust and thick at the continental crust. Now coming to the mantle, mantle can be divided into two parts, the upper mantle and lower mantle. Upper mantle and the lower mantle. Okay, so remember, very important point, that the crust, entire crust plus upper part of mantle is called as lithosphere. Is called as lithosphere. The crust plus entire crust plus upper part of mantle is called lithosphere. Okay, so it extends up to 0 to 200 kilometers, varying on the place, and below this lithosphere, what is lithosphere? Crust plus upper part of mantle. Below lithosphere there is a semi-liquid state matter in mantle. There is semi-liquid state matter in the mantle, or it called viscous in nature, semi-liquid, jelly kind of structure, nature, state of matter below, just below the lithosphere in the mantle. It is called as asthenosphere. Asthenosphere is a semi-liquid state, or what you call viscous in nature material. Okay, so we can say that this lithosphere is floating on asthenosphere. So the movement in the asthenosphere is responsible for the movement of this lithosphere. Okay. So crust plus upper part of mantle is called lithosphere. It is proper solid structure, and beneath that around 200 to 400 kilometers you have asthenosphere, which is semi-liquid in state. Okay. And then rest you have mantle, which is completely solid in nature. Only this part is semi-liquid in state. Okay. Right. So what is lithosphere? Lithosphere is crust plus upper part of mantle, and lithosphere literally floats on asthenosphere, which is semi-liquid in state, and rest of the mantle majorly is a solid part. So it extends from crust to mantle here. So what we have covered? Of course, as you move to the lower part, the density increases. So the discontinuity, the mantle extends from Moho discontinuity to 2900 kilometers. The density and temperatures when compared to the crust is high. So mantle is divided into the upper and lower mantle. So the upper portion of the mantle is called asthenosphere, where it extends up to 400 kilometers. It is weak zone, and it lies below the lithosphere. And what is lithosphere? Lithosphere is nothing but the crust plus uppermost part of mantle is called lithosphere. Okay. So this is about the mantle. Then moving on to the third layer, innermost layer of the earth interior, that is the core. That is the core. Okay. So the core can be divided into two parts, the outer core and the inner core. The outer core and inner core. So the outer core, interestingly, it is liquid in state, and the inner core is solid in state. Now you may get a doubt, why liquid in state and solid in state? See, the outer layer of the core is liquid in state because as you move to the interior of the earth, temperatures increases. Temperatures increases. So temperatures are high in the outer core. Because of that, the matter is in liquid state. Where? In outer core. And once you get into the inner core, it is solid in state. Sir, you may get a doubt once again that if temperatures are higher in outer core, inner core is next level, that is next in the interior. So temperatures must be higher than the outer core. But why the inner core is in solid nature? Simple reason, though the temperatures are higher in inner core when compared to the outer core, along with the temperatures, you also have high pressure in the inner core because of the overlying layers. Apart from having high temperature, inner core also has high pressure. So because of this, it is solid in nature. It is solid in nature. So outer core is liquid in state and inner core is solid in state. Okay. So the mineral composition, if you see crust, you have, it is dominated by Sial, Sima, and it is knife, nothing but silicon and aluminum. Crust is dominated by two minerals, silicon and aluminum. The mantle is dominated by Sima, silica and magnesium. Okay. And the out core is dominated by nickel and ferrous. Knife, nickel and ferrous, chemical composition. Sial, Sima, knife, silicon aluminum, silicon magnesium, and nickel and ferrous. Now, so as you go to the interior of the earth, remember one thing, that the temperature and pressure might not increase at same rate, but definitely will increase. Let us say for 10 kilometers, if temperature increases for 1 kilometer 1 degree, and next 5 kilometer only 1 degree temperature might increase, but the temperature definitely will increase as you go to beneath the earth surface, but not at same rate. Remember, pressure and temperature will not change, it is on at same rate, but definitely they are going to increase. Now one more point that you have to remember is the discontinuities. Discontinuities. What are these discontinuities? Here you can see. So you know that the crust, mantle, core are of different material, different composition, right? So there must be a changing layer. So these changing layers have been identified by different geologists, and you can see that the crust and upper part of mantle is divided by Moho discontinuity. Moho discontinuity between crust and mantle. And then this is important, Gutenberg discontinuity between mantle and outer core. Mantle and outer core is differentiated by Gutenberg discontinuity. And then you have Lehman discontinuity between the outer core and inner core. So the discontinuity between crust and mantle is moho. Okay. Then the mantle and outer core is Gutenberg, and inner core and outer core is Lehman discontinuity. Right. So, here look at the point here, the temperature increases towards the center of the earth, however, the rate of increase of temperature is not uniform from the surface towards the earth center. Now, one more important point here, that the material that is available in the earth crust and entire earth. So, as I told you, the earth crust is dominated by Cl, silicon and aluminum, okay, and it is oxygen is also available, elements that matter. So, it is oxygen, silicon, aluminum and iron are the what you find in the top crust, whereas in the interior of the earth, if you take the entire earth, then the dominant mineral is iron, oxygen, silica and magnesium. So, in the crust you find oxygen, silica and aluminum, here iron, oxygen, silica and magnesium, entire earth. This is the composition here. Okay. So, that is about the interior of the earth. Now, moving on to the next topic, that is rocks, rocks, the rocks and classification. So, what are rocks? So, rocks are nothing but the building material of the what you call the surface. Okay. So, when you look out, you find different type of rocks, some are soft, some are hard, some are red in color, some are white in color. The texture is also different. Okay. So, all these rocks can be classified into three families based on mode of their origin. They can be classified into three family groups based on their mode of origin, just like how life is divided into plants, flora and fauna. Within that, in fauna you have mammals, reptiles, birds and all. Here rocks can be classified into three types based on their formation. So, what are they? The rocks can be classified into three types based on their formation. Okay. The one is the first igneous rock, sedimentary rock and metamorphic rock. So, the igneous rocks, metamorphic rock and the sedimentary rock, these are the rocks you can see, igneous, sedimentary and metamorphic rock. So, we will detail discuss about each type of rock and with examples, okay, how they form and what they do. So, first starting with the igneous rock, it is a basic primary rock. Why I am calling this rock as primary rock? Because for sedimentary rock and metamorphic rock, you require a pre-existing rock, that there should be a rock and that rock will transform into sedimentary or metamorphic rock. But for igneous rock, it is a primary rock, directly the rock forms into igneous rock. It do not need any pre-existing rock. Okay. And how igneous rocks is formed? Igneous rock is formed by solidification of lava. So, you know that whenever there is volcanic eruption, the lava comes out, and when the lava comes out, the exterior temperatures are cool. So, this lava solidifies, and solidified into and forms into rock called igneous rock. The rocks which are formed by solidification of lava is called igneous rock. Igneous in Latin word means fire, formed out of fire. Okay. So, best example for the igneous rocks are, you can see the granite, basalt, okay, the pumice, granite, basalt, pumice. You can see these are very hard rocks. So, that is why they are used for construction. They are formed by solidification of lava. They are called primary rocks. Okay. Since they are formed by the solidification of lava, which is coming from the interior of the earth, they do not contain any fossils. They do not contain any fossils because they are directly coming from the lava, and these rocks are hard and resistant, very hard and resistant, and you cannot find layers. Since they are formed of single material, you do not find any layers, do not find any fossils here. So basically these rocks are hard and resistant. They are formed by solidification of lava or magma. Then next, once again the igneous rocks can be classified into two types. The igneous rocks can be classified into two types. One thing, the rocks which form beneath the earth's surface and the rocks which form on the surface and beneath the surface. Now what is the difference? See, because of intense heat, as you know, at the asthenosphere level, the rocks are in molten form, that means rocks are in liquid form. So when this molten form of rock is beneath the earth's surface, it is called magma, and once it comes out, it is called lava. Okay, so beneath the earth's surface there is magma, and when it comes out, it is called lava. So sometimes this lava within the earth's surface, beneath the earth's surface itself, it cools down. Cools down. Such kind of rocks are called intrusive igneous rock. Intrusive inside the earth, they are forming intrusive igneous rocks. And certain rocks which form on the surface, by solidification of lava, it is called extrusive igneous rock. Extrusive igneous rock. So what is the difference between the extrusive igneous rock and intrusive igneous rocks? Yes, both are formed with same material, but the thing is, when a rock is formed beneath the earth's surface, the lava or the magma cools down slowly because temperatures are high. And whereas the extrusive case, when the lava comes out, the outside temperatures are cool, so this rock will solidify quickly. Extrusive rocks solidifies quickly, intrusive rocks solidifies slowly. Okay, and because of this, you can find a difference in the rocks, that you can see the intrusive rocks, you can find large black crystals in the intrusive rocks. Why? Because in the intrusive rocks, in order to lava to solidify, it takes more time. So in this time, crystals are formed, and the rocks which are formed on the surface, they cool down quickly, so there is no scope for forming of crystals between. Okay, so best example here, intrusive and extrusive rock, is this. Solidifies quickly, so no crystals. Solidifies quickly, so it is slowly, so you have large crystals here. Okay, and yeah, so intrusive rocks are also called as plutonic rock. Best example for this is intrusive rocks is granite. In granite you find crystals. Right? Granite lo crystals, you find crystals here. But in the extrusive rocks like basalts, you do not find anything. Basalt is pure black, there is no crystals in it. Okay, so the next set of rocks is nothing but the sedimentary rock. So what is sediments? So basically, already a pre-existing rock. In order to form into a sedimentary rock, it need a pre-existing rock. Okay, so a rock gets weathered by sunlight or by rainwater or by glaciers. So these rocks divides into bits and pieces. Okay, this is nothing but they are called as sediments. Okay, so already a pre-existing rock, it may be igneous rock or a metamorphic rock. Pre-existing rock, under the weather, intense heat, sun, glaciers movement, all this rock gets baked biologically or chemically or physically. The rock may get disintegrated and forms into pieces, and this debris is called, we call it as sediments. Okay, so when these sediments, generally when they are carried by glaciers or winds or by running water, they are deposited somewhere by these sediments by running water or by glaciers or wind. These sediments are deposited, okay, at the bottom of the lake or an river basin. Okay, and these sediments over a period of time get cemented and form into a rock. Okay, sedimentary rock is nothing but a rock formed by sediments of already a pre-existing rock. So rock gets disintegrated, forms into sediments, and these sediments carried by the wind or glacier or running water, they get deposited, and when they get deposited, they get cemented and form into a new set of rock. It's called sedimentary rock. So sedimentary rocks are nothing but the rocks which are formed by the sedimentation. Sedimentary rocks are those that are formed through the deposition. So cementation is nothing but lithification, the word compaction, cementation, you can use the word lithification of the sediment particles of the earth's surface. Okay, so if it is a tiny particle, we call it as clay. If it is little more, it is called silt. It is even bigger than that, then it is called sand, pebble, cobble and boulder. These are all the sediments, and these sediments get grouped and formed a rock. So you require a pre-existing rock to form a sedimentary rock. Okay, so you do not find any crystals in sedimentary rock because they are not formed by cooling, right? But often sedimentary rocks consist of fossils. See, igneous rocks comes from, they are formed by the solidification of lava which comes from the interior, so there is no chance of formation of fossils as it is hot. But sedimentary rock, they are formed by the sediments of pre-existing rock, okay, and they are carried by rivers and glaciers to different places, and when they get deposited, there are high chance that fossils may get into this rock, okay. So that is why sedimentary rocks are known for fossils, they are known for fossils. So high chance of getting these things, and since this sedimentary rock is formed from different rock material, you also find layers in this sedimentary rock. Layering can be seen, fossils can be seen in sedimentary rock, but you do not find any crystals, whereas igneous rock you find crystals, but you do not find any stratification, layers or fossils in it. Okay. So what are the best example for sedimentary rock? Best example for sedimentary rocks, here you can see the sandstone, you can see the different layers in it, or you can see the shale, you know the shale region is known for shale gas. So you can see they are formed of different material here. Similarly, conglomerate, you can, if you look at here conglomerate, you can see that it is formed of different particles, limestone, chert, sandstone, shale, these are all formed by the different materials. So these are all sedimentary rocks. So these sedimentary rocks may be formed organically, chemically or physically, okay. Mechanically by means the fragments get attached and form into one material. Conglomerate, best example. By some rocks are formed by organically, that means for example if you see corals which are under the sea, these corals by excreting materials or their bones, they may get compacted and form into another set of rock. So biologically forming, organically rock. Some rocks are formed chemically, for example if you take rock salt is formed in the oceans, okay. So at the near to the coast, the ocean water collects there and the salts gets evaporated and they form into rocks. Such type of rocks are called the chemical rock. Anyways, this classification is not important, you should know what is a sedimentary rock. Sedimentary rocks is formed by the lithification or cementation of the pre-existing sediments of a rock. So gypsum, chert, rock salt are examples of the sedimentary rocks as well. So in sedimentary rock you find fossils. Then moving on to the third set of rock, that is metamorphic rock. Metamorphic rocks. So what are metamorphic rocks? The rocks which are pre-existing rock, either it may be the igneous rock or a sedimentary rock. A pre-existing rock, if it gets transformed under high temperature and high pressure, a pre-existing rock, either it may be sedimentary or igneous rock, under high temperature and pressure, these rocks will turn into metamorphic rock. So best example, if you find rocks on the earth's surface, right? So whenever there is an earthquake, these rocks may go beneath the earth's surface, and if they go beneath the earth's surface, what happens? They come under extreme pressure and temperature. Because of that, these rocks may transform into other set of rocks called as metamorphic rocks. So what are metamorphic rocks? A pre-existing rock under high temperature and pressure, naturally it turns into a metamorphic rock. Let me give an example for this. So under heat and pressure, a rock will transform into metamorphic rocks. So what are the examples? Limestone, if it goes beneath the surface, high temperature and pressure, it turns into marble, okay. limestone, marble, sandstone, it turns into quartzite. Granite will turn into igneous. See, granite is an igneous rock, we have discussed, but under heat and pressure it will turn into a igneous. Igneous is an metamorphic rock. Similarly, coal is an sedimentary rock, right? So this coal, under the influence of heat and pressure, it will turns into graphite. Similarly, shale is an also a sedimentary rock, it turns into schist. These are all metamorphic rocks, right? So under heat and pressure, the shale transform into the other rocks. Igneous, slate, schist, quartzite, marble, these are all examples of metamorphic rocks. Okay. So one point, yeah. Some metamorphic rocks, you can find foliations on certain rocks, and some rocks you do not find any foliation here. So under extreme heat and pressure, the minerals in the rock squeeze and forms foliations like this, and some rocks do not form foliations. So this foliation and non-foliation can be seen in metamorphic rock. And now moving on to the last topic of this the rocks topic, that is the rock cycle. Rock cycle. What is rock cycle? Simply see, so the magma or the lava solidifies, form into igneous rocks. If these igneous rocks break into smaller and other pieces, mix up with the other one, get cemented, it forms into sedimentary rock. And if this sedimentary rock goes beneath the earth's surface, under heat and pressure, it will turns into metamorphic rock. And once again, if the metamorphic rock goes beneath the earth's surface, under the heat, it will turn into a magma, and once again if it comes out, it forms into igneous rock. So there is a cycle here, and there is no need that igneous rock should first convert into sedimentary rock and then sedimentary rock into metamorphic. No, igneous rock may directly form into metamorphic rock, or a metamorphic rock may form into sedimentary rock. Anything can happen. So how this process is possible? So magma solidification, igneous rock is formed, and this weathering erosion, when the rock disintegrates, it forms into sediments, and when it deposits, it is carried and deposited somewhere, and the deposition, when they are deposited, it gets cemented and form into sedimentary rock. Under heat and pressure, it turns into metamorphic rock. Or if metamorphic rock goes beneath the surface, melting, it turns into magma and forms igneous rock. Or igneous rock may directly form into metamorphic rock under heat and pressure, or a sedimentary rock may directly form into the sediments and form into further rock. So any rock can turn into other. So no rock will remain in the same state for long period of time. It is keep on changing. So this is about the rocks and rock cycle. Okay, the earthquakes. So earthquakes, you regularly come across the news that Japan, there was an earthquake, there was an earthquake in Nepal, sudden tremors in Delhi, or the recent news that there was an earthquake in Myanmar and Thailand. Okay, so what are these earthquakes? Why do they occur? Why do they are restricted to a particular place? Why do you not find earthquakes everywhere? And what are their implications? And what are the relation between these earthquakes and tsunamis? These things we will be detailedly discussing here. Okay, so first thing, so these are the scenes what you see during an earthquake, after the occurring of an earthquake. Sometimes you find a mild cracks, or sometimes you can see big buildings collapsing. Okay, so it all depends on the magnitude of the earthquake. We will come to know what is magnitude and this intensity of earthquake here, right. So first we will look into the earthquake causes and then earthquake prone zones and tsunami here, right. So what is an earthquake? Simply, an earthquake is a motion of the ground surface ranging from a faint tremor to wild motion capable of shake buildings. Just now we have called. So earthquake is a motion of the ground. When there is an earthquake, you can see the sudden movement on the shaking of the earth. Sometimes it may be very faint that even we can't recognize, and sometimes they are capable of collapsing buildings. Simply we can say that earthquake is a shaking of the earth. It is a natural event. Okay. It is caused due to the natural release of energy, and the waves are generated in the form of the energy is released in the form of waves. I will explain. Okay. So in general, what happens? Between the rock slabs, there are cracks, there are faults. Okay. So within the rock there will be a fault line. What is fault line? A thin sharp break in the rock is called fault line. Okay. So, what happens along the fault line? One rock tend to override on the other. Okay. Within the rock, then sometimes you may find fault. Fault is nothing but a sharp gap. The red one what I was saying is a gap here. So, when the two rocks, when there is along the fault line, the two rocks tend to move over each other. They tend to move over each other. So, initially friction between the two rocks holds them. Initially friction between the two rocks will hold them. So, all the energy is trapped. Once when these two rocks overcome the friction, the whole energy which is released, all the energy that is trapped, it is released in the form of waves, and these waves are called seismic waves. Okay. So, what is an earthquake? So, along a fault line, two blocks tend to override on the other. Initially with the friction, the energy is trapped, and once they overcome this friction, all the energy which is trapped, it is travels in the form of waves in the beneath the earth surface. This is called an earthquake. Simple term, what is an earthquake? An earthquake is a simple word, the shaking of the earth. It is a natural event. It is caused due to release of energy. And how this energy is released? It is energy released from the form of waves, and they travel in the all direction. I hope it is clear what is an earthquake. Okay. Now, the point where generally the earthquake originates in beneath the earth surface, where the point, so along the fault line the earthquake originates. The point where the earthquake originates is called focus. It is called focus, or it is also called as hypocenter. It is called as hypocenter, focus or hypocenter. And the point perpendicular to the focus on the surface is called as epicenter. It is called as epicenter. The point where the earthquake originates is called as focus, and the point ahead perpendicular to the top is called epicenter. It is called epicenter. See, so earthquake maximum travels in the body of the earth. We call it as body waves, and when these waves touch the surface, another set of waves are generated, that is called surface waves. Now, surface waves are dangerous. Body waves only travel in the beneath the earth surface, they are not dangerous for us. But when these waves touch the surface waves are generated, and these surface waves are responsible for the damage that you see on the earth surface. Okay. The point where earthquake originates is called focus or hypocenter, and the point exactly perpendicular to it on the surface is called epicenter. Okay. So, if the distance is minimum between the focus and epicenter, the damage will be maximum, right? And if the focus is deep beneath the earth surface, the waves by the time it reaches the surface, they cool down, the energy decreases. As a result, when the earthquake, see, the focus point is, distance is high, effect is less, but if it is close, then you can see huge damage. Okay. Now, what are the reasons for earthquake? What are the reasons for earthquake that you see? Okay. Just now we have discussed that the point epicenter, just above focus, just above the perpendicular, you find epicenter. Right. First reason for the earthquake and for the prominent big earthquakes is the tectonic activity. Now, what is a tectonic activity? Simple. You know, the crust plus the upper part of mantle, the crust plus upper part of mantle is called lithosphere. We have discussed this in interior of the earth, right? Crust plus upper part of mantle is called lithosphere, and this lithosphere is floating on asthenosphere. As I told you, it is a liquid in state. It is liquid in state, semi-liquid in state in the mantle. So, this lithosphere is floating on asthenosphere. So, because of the convective currents in the asthenosphere, the plates move. So, basically literally the lithosphere floats on asthenosphere, and because of the movement in the asthenosphere, the plates also move. So, these plates either they move towards each other, that means it is called convergent plate boundaries, and or these plates may diverge, it is called divergent plate boundary or these plates may just slide past each other, it is called transform plate boundary. They either they move towards each other, convergent, either they may diverge, move away from each other, diverge, or they just slide past each other. The plates may move in three types: converge, diverge, and transfer. In all the cases you find earthquake. When two plates move towards each other, away from each other, slide past. When plates move, make sure that they create an earthquake. Okay. So the most common and ones are the tectonic quakes. All the earth looks like a pretty solid place from the surface. It is actually extremely active. Okay. Actually, the earth surface lithosphere is divided into plates, and these plates are moving. Okay. And you may get a doubt that, sir, if plates are moving, it should be visible, right? See, these plates move 2 to 3 centimeters every year. And can you notice them moving them 2 to centimeters every year? No. But over a period of time, thousands of years, you can notice that this plate has moved from this place to so and so XYZ place. Okay. So this is the tectonic plate. So if you look at the boundaries here, see the violet dots indicating the earthquake, red dots indicating the volcanoes, and the green dots indicating the mountain changes. See, the black points you are seeing indicating the convergent plate boundary, the brown one indicating the divergent plate boundary, and in yellow indicating divergent. See, convergent, divergent, transform. And wherever there is boundary, look at here, wherever there is boundary, all the cases you are finding the plate boundaries, all the places you are finding an earthquake. See, okay. So you always find in the news that Japan has an earthquake. Why? Because you can see there is a plate boundaries in Japan. There is plate boundaries in Japan. So that's why Japan is known for earthquake. Similarly, India also, there is no active plate boundary in peninsular India, but Indian plate is colliding with the Eurasian plate here. Indian plate is colliding with the Eurasian plate. That's why the Himalayan region is always prone to earthquake. Always prone to earthquake. The recent one also is part of this Myanmar earthquake. Okay. So wherever there is a plate boundary, you can find earthquake in that region. So these plates move. So whatever you are seeing in the world map is not that continuous. It is broken pieces, and these broken pieces are moving because of the movement in the astrosphere. Okay. So this is about earthquakes. Earthquakes occur majorly due to the plate movements. This, why the plates move? Because of the movement in the astrosphere below it. Okay. And these tectonic activity, the plates which are moving because the earthquakes which occur because of this plate movement are dangerous. Okay. They cause huge amount of earthquakes. So why Himalayan region is prone to earthquake? Because there is a plate boundary. Indian plate is colliding with the Eurasian plate even today. That's why the elevation of Himalayas is increasing. So that's why you find earthquakes over there. Okay. So in all the cases you find earthquake here. Then next is the volcanic earthquake. Volcanic earthquake. Now what is a volcanic earthquake? Same associated with this plate movement. See, when there is a volcanic eruption, huge amount of lava comes out. The huge amount of lava comes out with a great force, right? So when this huge amount of lava from beneath the earth surface comes with great force outside, it causes movement in the plates, blocks, causing earthquake. Okay. So the special class of tectonic earthquake is sometimes recognized as the volcanic earthquake. Earthquakes are produced by stress changes in the solid rock due to injection or withdrawal of lava. If the lava is withdrawn with a great stress, creating earthquake. So wherever there is a volcanic activity, you also find earthquake over there. Then along the fault zone. So this along the fault zone, just now we have discussed that wherever there is an gap in the big rock, when slab, there is a crack. So rock tends to override on each other, causing earthquake. And the fourth one is, all three what we have discussed is natural, and fourth one is anthropogenic, human-induced earthquake. How humans are responsible for earthquake? First thing, you all know, in order to extract coal, iron ore, what we do is we do mining. We go beneath the earth surface. Okay. For example, let's say, this is a rock. So you know that this particular region you have coal belt or iron ore belt. What you will do? You dug deep here, extract coal from this layer. So entire coal is vanished now, there is nothing there, but the stability which this upper layer rocks are given by the beneath surface, now it will lose. That means you are like removing the pillars in between. So what happens? It will collapse one day. So this mining activity can also trigger an earthquake. Roofs of a collapse may go down. And then explosion, conducting nuclear, for example, you know when a nuclear bomb experiment conduct in the ocean or in the land, it creates huge amount of explosion. So this explosion also responsible for the shaking of the earth. They may also create tremors. And the next category is the reservoir induced earthquake. It is called RIEs, or the reservoir induced earthquake. What happens when you construct a dam? So generally dams is constructed for a good purpose, that is for storing the water and divert the water whenever there is a dry period. So generally we construct a dam. Okay, so when you construct a dam, huge amount of water is stored in that area. So naturally that area is not able to store the water. Naturally water is not storing over there. Basically you are constructing a big dam and huge cusecs of water is stored in that area. So when you store this huge cusecs of water in that region, what happens? The rocks lying below this region may get disturbed because of this overweight of the water, okay, and may cause earthquake. So there is a river called Koyna, which is a tributary of river Krishna, Koyna in Maharashtra. So they have constructed a huge dam in Koyna region on the river Koyna. So there was an earthquake in that region. Okay. Now imagine, so generally hilly areas are suitable for constructing dam because that hilly areas will act as a natural barrier. So they will construct a small structure here, so storing the water. And hilly areas also suitable for generating hydroelectricity. Why? Because water in hilly areas come from great height, and when they fall on the turbines rotate and it will generate electricity. So hilly areas are more suitable for constructing hydroelectricity projects. In Himalayan region we are constructing hydroelectric projects. So when you construct these projects in sensitive regions like Himalayas, it will further trigger earthquakes. So that's why we should avoid constructing dams in sensitive areas. So mining activity, explosions and reservoirs. And of late we are more using the water, we are not using water judiciously, we are digging bore wells everywhere. Okay. So what happens when you dig bore wells everywhere? Let us say this is an area. So someone is digging a bore well here, someone here, someone here, someone here. So as a result, what happens? You are disturbing the internal rock structure. And one day it may collapse and lead to earthquake also. Okay. So in the month of December, there was in Telangana there was a minor earthquake, right? So because of in the mining activity region, in Ramagundam, Peddapalli region, this is the mining activity region. So this is human induced earthquake. Earthquakes can be based on depth. Shallow means it is not of great depth. Intermediate means medium. Deep means have focus around 300 to 700 kilometers. So most dangerous are shallow earthquakes because the distance between focus and epicenter will be less. So damage is maximum in the shallow earthquake. Intermediate, medium and next in deep. Okay. Right. Next topic, important one, that is how do you measure earthquakes? How do you measure earthquake? So we use two scales to measure earthquakes. We use two scales to measure earthquake. One is the magnitude. To calculate the magnitude, we use a scale called Richter scale, and to measure the intensity of the earthquake, we use a scale called Mercalli scale. Now, what is magnitude? What is Richter scale? We will discuss. Important, very important in assessing the earthquake in a particular region. See, the amount of energy released during an earthquake is called magnitude. The amount of energy released during an earthquake is called magnitude. And what is the scale that you use to study about the magnitude? That is Richter scale. Richter scale is a scale used to measure the magnitude of earthquake. Richter scale is from 0 to 10. 0 to 10 is the scale of Richter scale. So Richter scale is used to measure the magnitude of earthquake. Okay. So, with each number increasing from 0 to 1, 1 to 2, that means 32 times energy is released more. Okay. Then intensity. Intensity of an earthquake means the amount of damage done by earthquake. Amount of damage done by earthquake is called intensity of earthquake. So, the scale we use is Mercalli scale. The scale we use to measure the damage of the scale we use to measure the damage done by earthquake is Mercalli scale. That is, in order to measure the intensity, you use Mercalli scale. So, Mercalli scale reading is from 1 to 12. 1 to 12. So, the amount of energy released during earthquake is magnitude, and the scale that we use is called Richter scale. It is reading from 0 to 10. And intensity, the amount of damage done by an earthquake is measured by Mercalli scale, that is from 1 to 12. Okay. See, so this is just for your understanding. This is one side we have intensity, and other side we have magnitude. Okay. So, if the magnitude is around 3.5, when the magnitude is 3.5, only it is detected by seismograph. Seismograph is the graph which used to study about the earthquake. So, you cannot feel, if an earthquake is 3.5, you cannot detect an earthquake, just on seismograph you can study. But if the earthquake is more than that, if it is around 3.5 to 4, only sensitive people can feel that. If it is around 4.2, magnitude is 4.2, felt by people who are indoors, that means building shake and all. And if it is more than that, it will be felt by all. And see, if it is 5.5 to 6.1, everybody runs out of the doors. That means the intensity is maximum here. And once the earthquake crosses this 6.2, 6.9 range, then the damage is very destructive. So, everyone, considerable damage will done, collapsing, all these things takes place. 6.9, ground cracks, buildings. If it is around 7 to 7.3, many of the buildings get destroyed. 7.4 to 8.1, only few buildings will remain in standing, and if it is more than 8.1, total destruction. So, that is why anything above 6, 6.5, 6, 9 is dangerous. The magnitude scale, if it is more than 6, 6.5, it is dangerous because the damage intensity will be more. Okay. Then effects of an earthquake, you all know, ground shaking takes place, ground resettlements, land and mudslides will take place. So, in the hilly areas, the landslides and mudslides may take place, soil liquefaction, ground lurching, avalanches may take place. Now, what is soil liquefaction? Simple. See, this is what naturally a normal condition, this is how it looks. Okay. The gap between soil particles is very less. Okay. So, the soil is strong over the bedrock. This is normal conditions, and during an earthquake what happens? Because of shaping, because of the shaking during earthquake, the sand particles distance increases. So, when the distance of sand particle increases, the soil becomes loose and buildings collapse. This is called soil liquefaction. This generally takes place during an earthquake. Okay. And what you are seeing is avalanches. Avalanche is nothing but the mountains which are covered with snow during an earthquake, they get deep stabilized and come down slope. This is called avalanches. And in hilly terrain region, hilly regions, okay, when there is an earthquake in hilly region, what happens? There is a displacement of rocks and loose sand metal which may come down. So, this is called landslide. Landslides, this is called, when the snow comes out, it is called avalanches. Okay. So, hilly areas are more prone to these earthquakes. Okay. And one of the worst effects of earthquakes is tsunami. It is tsunami. We will detail discuss how earthquakes are responsible for tsunami. So, just remember that tsunami, underwater earthquake, if the earthquake occur in the ocean, it leads to tsunami. I will detail explain little later after covering this point. So, tsunami is also, earthquake is also responsible for the tsunami. Underwater earthquake leads to tsunami. Right. So, just now we were discussing about earthquake waves, right? Earthquake waves is also called as seismic waves. Seismic waves. These waves are helpful in understanding interior of the earth. As we cannot go deep into the earth, by studying the movement of these waves in the earthquake, we can understand about the earthquake waves. So basically earthquake waves are of two types, body waves and surface waves. Body waves and surface waves. How? Simple. This is surface. Let us this focus. So during an earthquake, first set of waves that are generated are called body waves. Okay, and these body waves, when they touch the surface, another set of waves is generated, that is surface waves. Now there is no problem with these body waves, but the problem we have is with surface waves, because these surface waves are capable of displacing buildings, structures on the surface. So surface waves are dangerous. Body waves. So body waves, these body waves are of two types, P and S, primary waves and secondary waves. Okay, primary waves and secondary waves, and then surface waves. Now distribution of earthquakes. Distribution of earthquake, where you find most of the earthquake, the first thing is around the Pacific plate, the circum-Pacific plate, around the boundaries of Pacific plate. Pacific plate is interacting with this island plates, Australian plate, North American plate, that. And next in Alpine Himalayan belt, the Himalayan belt and the Alps mountain range of the mid-region, and then the Atlantic Ocean. These are the earthquake prone zones. Yeah, so this is the region where you find earthquake. So Pacific ring of fire, Pacific ring of fire, Pacific ring of fire, the Pacific or circum-Pacific belt, the boundary along the Pacific plate is a constantly interacting plate. Okay, so that's why you find more number of earthquakes, and also you find more number of volcanoes. So there are around 430 active volcanoes around this region, plate boundaries, and then the Alpine Himalayan belt, the Atlantic belt. So these are the places you find earthquake. And when it comes to India, 58% of India's landmass is known to earthquake. 58.6% of landmass is known to earthquake here. Okay. So most prone to earthquake is Himalayan belt. It is because at the plate boundary, tectonic region. Andaman Nicobar also at the plate boundary down south, and Deccan Plateau, because of, though there is no plate boundary in Deccan Plateau, but there are faults. There are faults and unscientific of construction, so that's why Deccan Plateau also you have earthquake. So considering all the previous history, Bureau of Indian Standard BIS has classified the earthquake zone in the country, grouped into 4, 2, 3, 4, 5. There is no one, remember, there is no one zone in India. So they have classified the earthquake zones into 2, 3, 4 and 5 zones. There is no one zone in seismic activity according to BIS. Now what are the places that comes under this region? So zone 2 means low intensity, zone 3 means moderate intensity, zone 4 severe intensity, zone 5 very severe intensity. So that means zone 5 regions are highly prone to earthquakes, followed by 4, 3 and 2, and there is no one complete zone, safe zone in India. Okay. So what are the areas that come under this place? Very important, that is your Himalayan region, Jammu Kashmir, Himachal, Uttarakhand region. Okay. The Nepal boundary of Bihar, northeastern states, and your the Rann of Kutch region. There is a fault here called Aliband fault. Because of this region, it is a highly prone earthquake region. What is that? Jammu, Uttarakhand, Himachal Pradesh, the Bihar, northern Bihar, northeastern states, and the Rann of Kutch region. Kutch. Okay. So this is a high prone region. The entire northeastern states, parts of Jammu Kashmir, Himachal Pradesh, Uttaranchal, Rann of Kutch are highly earthquake prone regions. 10% of India is under this region. Then the 4 remaining parts of Jammu, Kashmir, Himachal Pradesh, the NCT Delhi, okay, the orange one, Delhi is in 4th zone, is also prone to this. The surrounding areas of Kutch, the surrounding areas of 1 zone, you find the orange zones are the 4th one. And then you have 3, basically 3 zone covers the yellow part, okay, the yellow part, the central and peninsular India. Then you have the 3rd zone, the 2nd zone, the blue one, Okay. So, major prone regions are the 4 and 5 and 4. Okay. The Himalayan regions comes on that, and your important Delhi comes under 4. So, our region peninsular India comes under, the southern peninsular region comes under 2 safe zone, because there are no active plate boundaries, but because of human activities now we are seeing some earthquake in that region. Okay. So, that is about the earthquake. Okay. So, as I told you, at the end of the session I will be discussing about the tsunami. Okay. So, as I told you, what is the reason for tsunami? Underwater earthquake or marine earthquake, underwater earthquake may trigger a tsunami. Now, how tsunami occurs, how earthquake is responsible for tsunami, let us look into that. So, tsunami is a Japanese word, su means harbor, nami means wave, harbor wave. Okay. It is also called killer waves. Now, how they occur? See, if you look in the first picture, you can see there is an earthquake. On the ocean floor, there was an earthquake. Okay. So, when there is an earthquake, what happens? Water will displace. So, volume of water is displaced and pushing it up. In second case, you can see now similar, when you just stir the water in a bucket, what happens? They form into waves, right? Similarly, then because of this earthquake, then the water, because of the earthquake, the water has erupted and pushing it up, and because of that a series of oscillation waves are generated. So, initially what happens at the beach, the coast region, abnormally the coast will be visible, all the water will be drawn into the ocean. So, you can see abnormally the coast can be seen. Okay. So, when you are here, you are seeing that when the abnormally water is going back, that means it is a dangerous sign, you have to move from that area. So, initially what happens, an earthquake occur in the floor. So, because of this earthquake, water get displaced, a water series of oscillation starts, and the water initially pulled back, and then water with great speed they come towards the coast, and when with the great speed and elevation they will damage the coastal area. This is how a tsunami works. Okay. So, what happens in the tsunami when it is in deep ocean? When tsunami is in deep ocean, when the earthquake, the wavelength will be maximum, the the length between the each crust and crust will be maximum. Okay. And speed will be also maximum. In deep ocean, speed will be maximum, the wavelength will be maximum. Okay. And once these tsunami waves come close to the coast, what happens? The elevation decreases, speed decreases, but the depth decreases, speed decreases, but the elevation increases. Okay. So, when the tsunami is in the deep ocean, velocity is high and wavelength is also high because of the depth. Once the depth decreases, you can see, once the depth is decreasing, velocity is decreasing and wavelength decreases, and what increases is height increases. Endukante, see, when wavelength decreases, that means when the depth decreases, the wave size will increase. So, around the wave go up to 30 meters high, causing damage. Okay. So, as when the tsunami is in the deep ocean, velocity is high, wavelength is high, the distance between two crusts will be high, and when the depth decreases, the height increases, causing huge damage in the coastal areas. Okay. So, when you look at India, India is also not safe from tsunamis because we have a ocean plate boundary here in Pakistan, another ocean plate boundary in Sunda land. So, if you remember, there was a severe tsunami in 2004. So, there was a tsunami, there is a Sunda land. Sunda land means near to Indonesia. There was an underwater earthquake here, and the tsunami waves travelled all the way to Sri Lanka and Tamil Nadu, causing damage. Okay. Lakhs of people have lost their life because of this tsunami. Okay. See, this is a fault here, and similarly you have another fault near to Pakistan here called Makran point. So, here if there is an earthquake, this coast is vulnerable, that is the western side, and if there is any earthquake here, this coast will be vulnerable. Okay. So, tsunamis are very dangerous, but good thing about tsunamis is that you cannot predict an earthquake. You can predict an earthquake, you cannot take any precaution, it suddenly comes, but you can predict a tsunami. You can predict a tsunami. How? Because the tsunami starts in deep ocean. Anyways, if the distance between the coast and tsunami is low, we cannot do much, but when generally the tsunamis start in deep ocean and come to the coast. So if you notice any early abnormalities in the ocean, that means in the speed of the waves or wavelength, then if you can notice that, you can give an early warning system. So that's why we are using an early warning system to study about these waves. Yeah, this is the early warning system that we use. We use DART technology, deep ocean assessment and reporting for tsunami. What we'll do is, in the deep ocean, we'll put a surface buoy like this, okay, buoy, and it is connected to anchor in the depth, and this, if there is any abnormalities in the sea's wave speed or wavelength, it will report to tsunameter, okay, it will tsunameter, and from there the information is given to satellite and to the tsunami warning center. Tsunami warning center is in Hyderabad, Pragati Nagar, okay. So in the deep ocean, you will have a surface buoy, and if there are any modulations in the sea waves or speed, the information is given to the satellites, and from satellite you will get a tsunami warning system, and from this place tsunami information is disseminated. So this is called DART technology, okay. So this is about the tsunami. So in order to protect from tsunamis, the best way is of course to giving early warning system and constructing, in order to floods or tsunami, constructing a bioshield. Bioshield means constructing trees along the coastline will help from controlling tsunami and cyclones. Tsunami and cyclones. See, cyclone is purely a weather element, tsunami is completely related to geomorphology. Plate movements may lead to tsunami, and climatic change may lead to cyclone, okay. So that is about the earthquakes and tsunamis. So by this we have covered the important topics in geomorphology, where we have covered interior, okay, interior of the earth, rocks, and these earthquakes. The important topics that we need to cover related to climatology is that the factors influence the climate of a region, structure and composition, pressure belts, winds. So these are the important topics that we need to cover as part of climatology, okay, right. So first we will try to understand with the basic terms here, what is the difference between climate and weather. Difference between climate and weather. So basically we use this word climate and weather as interchangeably, but there is difference between weather and word weather and climate. So when you just Google to just Hyderabad's weather, if you just type Hyderabad's weather today, it will show you like this, okay. That is the temperature, precipitation, chances of precipitation, wind, atmospheric pressure and all, okay. And if you just type climate of Hyderabad, it will show this kind of graphs, indicating that the difference is, when you study, the elements of weather and climate are same, okay. Yes, for both weather and climate, elements are same: temperature, wind, atmospheric pressure, humidity, precipitation, rainfall, all these are same for climate and weather. But if you study these atmospheric elements for a period of time, let us say at a short period of time, if you study a temperature, precipitation, humidity, wind of a particular region for a short period of time, it is called weather, okay. And if you do same thing, if you study about temperature, wind pattern, humidity, atmospheric pressure of a region for a long period of time, that is called climate, okay. So when you ask about the atmospheric conditions of that particular day, it is called weather. How is the weather today? You won't say how is the climate today, because climate is for long period of time. If someone moves to Bangalore, you will ask him, how is the climate of Bangalore? That means you have not visited Bangalore, and you want to know how generally the climate of Bangalore is, okay. And the friend who has migrated to Bangalore, he will ask you, how is the weather in Hyderabad today, because he knows that how is the climate of Hyderabad. You want to know the weather, getting my point. Weather is temporary, climate is for long period of time, okay. So in life also, generally we expect things to be like, want things to be like climate, but actually they are weather. Things don't remain forever. Okay, so climate is for long period of time and weather is short period of time. Or you simply can say that like climate is like your character, it won't change easily, right? But weather is like your mood, it can instantly change, right? So that's the difference between climate and weather. And see, what to wear on that fine day is decided by weather, okay, and what to have in your wardrobe is decided by climate. If you go to Jammu Kashmir region, they will, in their wardrobe they will have more woolen cloths. In our South India, in the southern states, generally we have cotton cloths in our wardrobe. So that is true, but we also have woolen cloths, or the cotton cloth, it depends on weather. Anyways, so climate is of long measure of average pattern of temperature, humidity, atmosphere for long period of time, and weather is for short period of time. And we have 5 elements here, right? Generally temperature, pressure, humidity and precipitation. So we will have a small discussion over this topic. So temperature, what is temperature? See, heat is energy, heat is energy. If you state a body's hotness or coldness of a body, then it is called temperature. Hotness or coldness of a body, then it is temperature. Okay, heat is energy, you are just saying the temperature, that means is it cold or hot, that is temperature. Okay, and of course temperature depends on the vertical rays of the sun. If a particular region direct rays is falling, then it will have a warm temperatures, then if it is low, it will have a low temperature. Humidity, what is humidity? Presence of moisture, presence of moisture in the air is called humidity. Okay, moisture is nothing but water vapor, the presence of water vapor in the air is called humidity. Okay, so if air has more the air has more water in that means water vapor, moisture in that, then it feels dampy, right? Always it feels sticky. So if you move to Chennai, Vizag, Mumbai, these places, you always feel sticky weather conditions. Why? Because they are in the coastal areas. They are in the coastal areas, so constantly to the air moisture is added because they are close to the coastal areas. So that's why it always feels sticky in the coastal areas. And in the interior parts of the country, then dry conditions. Okay, then wind. So generally horizontal movement of the air is called wind. Okay, air has no direction, but wind has direction. Okay, air with a direction is called wind. Then precipitation. What is precipitation? Precipitation is nothing. In generally, what happens? General precipitation process. Okay, so what happens generally, because when there is hot, a sunny day, if there is a water body here, because of the heat, the water will absorb the heat from the sun, and now this water is turning into vapor. Water will turn into vapor. Okay, so along with this air, so it was in state of water here, now it is turning into vapor. By absorbing the heat from the sun, the water is turning into vapor. That is what, right? So when you heat a ball of water, what happens? Water will turn into vapor. Same thing is happening because of sun's heat, water is turning it into vapor. Okay, and when this vapor move to the higher altitude, at higher altitude temperature is low. In higher altitudes temperatures are low. So this vapor, when it moves to higher altitudes, all the temperature it will lose. Okay, once again it will turn into small droplets. This vapor is turning into small water droplets. It will turn into small water droplets, and the small water droplets will settle on the dust particles, forming clouds. Okay, so what you are seeing, because of the sun's heat and then a water body, water is getting vaporized. Okay, here you can see the vaporization is taking place. Okay, and when it moves to the higher altitudes, the temperatures in the surrounding areas will come down. So when temperatures in the surrounding areas come down, once again this vapor will turn into water droplets, settle on dust particle, forming clouds. Okay, this process is called condensation. Okay, condensation. vapor turning into liquids. Okay, and when this condensation takes place, when these water droplets meet each other, the size of the water droplet increases. Okay, and when the droplet size increases, the dust particle cannot hold, so it gives rain. It gives rain. Okay, so rain is a form of precipitation. Rain is a form of precipitation. If it is temperatures is below 0 degrees, then this takes place in snowfall, in the form of snowfall. If temperature is below 0 degrees, you take snowfall. If it is more than that, you see in the form of rain. Okay, so precipitation is nothing but it takes place in the form of rain or snow. Then another key point, atmospheric pressure. Atmospheric pressure. So there is, what is atmosphere, and then we look into the what is atmospheric pressure. So Earth is surrounded by mixture of gases. Earth is surrounded by mixture of gases, we call it as atmosphere. Earth is surrounded by mixture of gases, we call it as atmosphere. This atmosphere covers Earth's surface like a blanket. You have nitrogen, oxygen, carbon dioxide in this mixture of gases. Okay, so these gases are held by Earth gravity. These gases are held by Earth gravity. So Earth's surface is surrounded by a mixture of gases called as atmosphere. Okay, so this atmosphere, that means air has weight, right? So this air has weight. Okay, so the weight exerted by the air on the surface of the land is called pressure. So what is atmosphere? Mixture of gases. So this air has weight, right? And when the air puts pressure on the surface, then it is called atmospheric pressure. Air parcel putting pressure on the surface is called atmospheric pressure. Okay, atmospheric pressure. Now we should understand the difference, the relation between temperature and atmospheric pressure. Very important. Atmospheric pressure and temperature. See, on a hot sunny day, one example, and on a all chilly winter day. Okay, so what happens when on a hot sunny day with high sun will be overhead, and because of the sun's heat, the air above the surface, because of the high temperatures, the air above the surface will get heated up. Sorry, to be specific, the Earth's surface gets heated up. On a hot sunny day, because of sun's insolation, the Earth's surface gets heated up, and the air above the Earth's surface also gets heated up in contact, because air lies in the contact of ground, so it heats up. And when the air heats up, generally air or water, when it's heated, it expands. Okay, so here it expands. Here it expands. So when the air parcel expands, it becomes lighter and it will move upward. So what you are doing, when temperatures are high, Earth's surface gets heated up, and the air which is in contact with the atmosphere, the Earth's surface also gets heated up. And when it gets heated up, it absorbs the heat and it expands. And when it expands, it becomes lighter and move up. And when the air move up, will it exert pressure on the surface? No. It will not exert the pressure on, because air is moving upward, not downwards. So when temperatures are high, okay, when temperatures are high, the Earth's surface gets heated up, so the air absorbs the heat, it expands and becomes light, and it will move upward. And when the air moves upward, it will not exert any pressure on the surface. So that's why when temperatures are high, pressure is low, atmospheric pressure is low. You can see low pressure. Next, on a cool chilly winter day, temperatures are low, insolation is very low. Okay, so what happens, the air which is near to the ground, it is also cool, it is cold air. Cold air will not expand, instead it contracts. Okay, so cold air is more denser, cold air is denser, so instead of going up, it settles down, creating more pressure on the surface. So that's why when temperatures are low, you see high pressure. I hope you understand the relation. when temperatures are high, air expands and becomes lighter and move upward. So that's why the pressure exerted by that air parcel on the surface will be low. When temperatures are cool, the air will not expand, it becomes denser, weight increases, so it will create more pressure on the surface, high pressure, low pressure, high pressure. So temperature is inversely proportional to atmospheric pressure. If temperature increases, pressure decreases. I am talking about atmospheric pressure. And air always move from high pressure area to low pressure area. High pressure area to low pressure, just like how water move from highland to lowland area, how human beings move from high pressure to low pressure area, air also move from high pressure to low pressure area. Atmospheric pressure, wind always move from high pressure area to low pressure area. Okay. So temperature variation will affect the pressure, atmospheric pressure, and atmospheric pressure will affect the wind movement. So temperatures, when there is low pressure area or high pressure area, and because of this temperature winds move from high pressure to low pressure area. I hope it is clear. Okay, right. Next topic, the factors that affect the climate of a region. The factors that affect the climate of a region: latitude, altitude, distance from the sea, ocean currents, local winds, relief features, natural vegetation, slope, human influence. All these factors influence the climate of a region. Okay. So first foremost thing, we will detail discuss about each aspect. You know latitude very well, that the regions which are close to equator and tropics, equator is hot because the direct rays of the sun, and the temperature is warm, and the polar region is cold because simple thing, the sun rays directly fall on tropics and equator, and as we move to the higher latitudes, the rays are slanting. So that's why that regions are colder compared to the equator and tropical region. You can see in this map. So all the tropic region, you can see that they are very hot, and just above that you can see temperate regions, and the blue ones are the cold frigid zones. Okay, so we are in tropical region, so that's why we India we have always have high temperatures when compared to other. Next, altitude, most important factor. Okay, so do you know in summer destinations, in summer destination we go to Manali, Ooty, Kodaikanal, right? Why? Because plains, always remember, plains always have high temperature, and mountains, hills will always have low temperatures. Plains will always have high temperature, and the mountains, hills will also always have low temperature. Reason is why? Important point. The important point here, why? Because very important point, please focus here. So the sun's insolation, okay, the heat coming from the sun, you know that earth's surface is surrounded by mixture of gases called atmosphere. So the heat which is coming from the sun will not heat the atmosphere first, first with the insolation, that is the radiation coming from the sun heats up the earth first, okay. Solar radiation, the incoming solar radiation from the sun will heat the earth surface first, and once the earth surface gets heated up, the earth starts releasing heat. It is called terrestrial radiation, very important. So the incoming solar radiation coming from the sun first will not heat the atmosphere first, it will heat the earth surface first, and once the earth absorbs the heat, then it starts radiating the heat. We call it as terrestrial radiation, okay. And then this terrestrial radiation will heat the atmosphere. So atmosphere will not get heated up by directly solar radiation, earth atmosphere gets heated up by terrestrial radiation, remember, okay. So as a result, what happens? First the solar radiation will heat the earth first, and the earth surface will heat the layers. So now when these layers the layers of atmosphere, if it is close to the earth, obviously this layer temperatures will be high, because atmosphere, the sun is not eating the atmosphere directly, it is eating the earth surface first, then the layer then the atmosphere. So first the layers which are close to the earth are hot, right, and as you move far away from the earth, obviously temperature will decrease. So that is why elevated regions up to troposphere, the temperature drops with increasing elevation. Okay. So the solar radiation will first heat the earth surface, not the atmosphere directly, and after the earth gets heated up with the terrestrial radiation, the atmosphere gets heated up, and the air near to the atmospheric layers which are close to the earth are warm, and as you move to the higher altitude, the contact with the earth will be less, so temperatures are low. So that is why hilly regions are always cooler when compared to plains, okay. So with every 165 meters, this is average, for every 165 meters increasing elevation, temperature drops by 1 degree Celsius, okay. For every elevation, for every 165 meter elevation in the altitude, temperature drops by 1 degree Celsius. This is why when compared to the plains, hilly areas are much cooler, okay. That is why the summer destinations are Shimla, Manali, Ooty, Kodaikanal, Lonavala, Mahabaleshwar, these places, because they are much cooler when compared to this. And winters, they are extreme, okay. So this is called normal lapse rate. With every increase in 165 meters, temperature drops to 1 kilometer is called normal lapse rate. Then the distance from the sea. Distance from the sea. What is distance from the sea? The concept of distance from the sea. See, if you take example of Delhi, Kanpur, these places compared with the Kolkata, Chennai, Mumbai, Vizag, Goa, these places, any time of the year if you go to Mumbai, Kolkata, Chennai, Kochi, Goa, temperatures are almost same, there is no much difference between winter and summer, day and night, okay. But if you go to places like Kanpur, Delhi, for example matter Hyderabad, Chennai, you can see that winter temperatures may drop to 20 degrees, in Delhi like places it may go up to single degree also, and in temperatures in summer it goes up to 45 degrees. You can see this variation in interior parts, but in the coastal areas, temperature is not, there is no much difference between summer and winter, day and night, okay. Why? Because the sea always have moderating effect on the coastal areas, okay, because land heats up quickly and cools down quickly, but ocean water can hold heat for long period of time, and that means it takes more time to lose the heat and gain the heat, okay. So because of always of having a moderating effect of the oceans on the coastal lands, temperatures won't be much variation, and when you move close to the interior parts, when you go to the interior parts, there is variations in the temperature. So let me show you this with an example here, right. So if you look at the Goa, Mumbai, Chennai places, look at the average highs or lows, green or red ones, not both. So if you see, there is no much difference in temperature, 35, 35, 35, 35, 35, 30. Here Chennai same, 35, 30, 35, 30, 35, 30, 35, 30. But if you see Delhi and Kanpur, which are located in interior parts, you can see in winters temperatures are as low as 5 degrees and summers it is up to 40 degrees. You can see this variation. Same variation can also seen in Hyderabad. Why? Because we are looking in interior parts, no sea to moderate us. So that's why temperatures are extreme. Okay, I hope it's clear. Then ocean currents, we'll detailedly discuss about ocean current in oceanography. So as of now, remember, ocean currents are of two types. The surface ocean currents are of two types, warm ocean currents and cold ocean currents. So wherever the warm ocean current go, that will keep the coast warm, and wherever there is cold ocean current, that coast becomes cold, okay, it will have a cooling effect. in that region. Okay, we will discuss this is in oceanography. Let me give an example. So, there is an Gulf Stream which is a warm current which moves up to the Norway, Sweden, Finland. Okay. So, in winters are extreme in Norway, Sweden, Finland, right. So, water in this region freezes. So, the warm current which is coming from the Gulf Stream keep the coast of Norway, Sweden free from ice because it is a warm current. We will detail discuss about this in ocean current. Then local winds. The local winds also have effect on the climate of a local region, very local, small area. For example, Lu. Lu is an hot dry wind which originates in Sahara deserts and this wind blows in Haryana, Punjab, this region, keeping this region temperatures high in summer. Lu. Okay. So likewise there are other examples as well. Chinook, Nor'wester, Pampero, we will detail discuss about these local winds. We have a separate topic for that. And also the relief features. Relief features also influence the climate of a region. How? Simple. So if a mountain, rainy region, let me give an example, 2-3 examples, you will get the clarity. Here you have Western Ghats and you have Aravallis here. Okay. So the monsoon winds, the southwest monsoon wind, we will discuss this in monsoon. So the southwest monsoon winds come motion towards the land. So the southwest monsoons winds move perpendicular to the Western Ghats. Perpendicular to the Western Ghats. So what happens whenever the winds, warm winds coming from the ocean, they pick up the moisture. Warm winds can hold more moisture, and when it coming from the ocean, it has moisture in it. And when these winds hit the mountain range perpendicularly, it will get the elevation, move upward, and when you move up, it becomes cool. So whatever the moisture it has hold, it turns into small water droplets and settles on the cloud, dust particles, and form the clouds, and give heavy rainfall on the windward side. On the windward side, wherever there is a wind from the ocean. And what happens on the other side, the air which is there, it becomes dry because it has lost all the moisture giving rainfall on the western side, to be wind side to be specific, and the air becomes dry here. In the compression it also becomes hot. So one side they are on the same latitude, but because of the obstruction of this mountain, now one side will get more rainfall, other side will not get any rainfall. Here it is called windward side. Windward side. So on the Western Ghats, you have Marathwada, Telangana, Rayalaseema Plateau and Karnataka region. These are the rain shadow region of Western Ghats. Here on the western side of Western Ghats, this region receives more than 200 centimeters of rainfall. You find lush green vegetation over there, and the rain shadow region of the Western Ghats, that is this region, the Telangana Plateau, the Marathwada region, Karnataka, this region, it is a dry region. It gets low rainfall. Why there is in modification here? Because if there is no mountain here, the rainfall would be almost same, with more or less same amount. But since there is a huge mountain chain across the western coast of India, so Western Ghats receives more than abnormal rainfall and other one receives less rainfall. Okay. This is called orographic effect. Orographic effect, the mountain effect. Okay. Similarly, in India, we have big chain of mountains in the north, right? There are the Himalayas here. You find Himalayas in this region. So Himalayas protect us from the cold winds coming from Central Asia. If there are no Himalayas here, then cold winds make the North India much chiller. Temperatures may go below -°C. And similarly, it also protects of monsoon winds going from away from India. Okay, it gives rainfall and good. So these relief features also have an effect on the climate of a region. Of course, the natural vegetation and soil. Okay, so forest areas are much always cooler when compared to the dry areas, because trees will not allow the sunlight to fall down, so it always have cool affecting region. And once if you move to a desert area where there is no vegetation, sun rays will directly fall on the land. So in the daytime temperatures are high and the nighttime temperatures are cool in the desert areas. Okay. And slope and shelter aspect. So slope and shelter aspect is specifically noticed in the temperate regions, not in India. So where the sun rays are slanting, only one side of the face of the mountain will get sunlight and the other side is devoid of that. Okay. So, because of that you can see the variations here, only one side gets used and the other side there is no. So, this slope variation. So, just it is seen in mid latitudes, wherever there is sunlight, good forest, and on the other side you do not find anything. Okay. And then human effect, human influence. What is the human influence? What is the human influence? Simple thing here, what we will do, okay. What is happening right now is, the source of light for us is heat, is sun, okay. So, the energy, the solar radiation which is coming from the sun is short wave, there is no much difference between each wave, okay. So, the radiation coming from the sun will not heat the atmosphere first, it will heat up the earth surface first, and in return when earth absorbs the heat coming from the sun, it radiates the heat called terrestrial radiation, it is called terrestrial radiation, and it is a long wave radiation, okay, it is a long wave radiation. So, solar radiation will heat the earth surface and the radiation coming from the earth is called terrestrial radiation, it is a long wave, okay. Now, what we are doing, there are certain gases in the atmosphere, carbon dioxide, methane, okay, sulfur dioxide, okay, and your water vapor, nitrous oxide, okay. Now, these gases are called as greenhouse gases, these gases are called as greenhouse gases. The concentration of these gases are increasing because of our pollution through vehicular pollution, industrial pollution, what not, right. So, what happens, why we are very much worried about increasing of carbon dioxide concentration, methane, carbon dioxide, sulfur, water vapor and nitrous oxide, because we are not worried about increasing concentration of oxygen, but we are worried about these gases, because the nature of these gases is they are transparent for incoming solar radiation. Whatever radiation that is coming from the sun, they are transparent, they will allow the radiation to come, well and good. But the problem is, whatever the radiation, after absorbing the heat, earth also radiate the heat back, maintaining the heat balance, it absorbs the 100 units and also send back the 100 units roughly. But what these gases are doing, carbon dioxide, methane, these gases are doing, they are not allowing the heat coming from the earth to go into the space. As a result, what happening, temperatures on the earth surface are increasing. This is called as global warming, okay, this is called as global warming. So, the gases like carbon dioxide, methane, nitrous oxide, sulfur dioxide, they are transparent to incoming shortwave solar radiation, but whatever the radiation that is coming from the earth, they are not allowing it to go into the space and they are holding it. So, because of this, the temperatures on the earth surface are increasing, this is called as global warming, okay, this is called as global warming, and this is how we are influencing the climate of the earth, okay. So, we are talking about climate change takes place very slowly, it takes thousands of years, but because of the increase in this greenhouse gases, the temperatures are increasing and causing damage to the environment, okay. So, this is about the factors which influence the climate of a region, right. Then composition of atmosphere, So, what is this composition of atmosphere? You know that earth surface is covered by mixture of gases, we call it as atmosphere, okay. So, this atmosphere, what are this mixture of gases? That is nothing but composition, studying about the composition here. So, what is the composition here? Nitrogen is around 78% of the entire atmosphere we have, percentage of volume. Oxygen 20.95, okay. Carbon dioxide 0.036, argon 0.93. See, carbon in few amount of carbon dioxide in atmosphere is good because it maintains the heat here, but the concentration of, we are worried about the rapid increase of concentration of carbon dioxide in the atmosphere because it is trapping the heat, okay. So, 78.8%. So, if they may ask you to arrange this composition of atmosphere in increasing or descending order. So, descending order, first is nitrogen, next oxygen, then argon, not direct carbon dioxide, it is carbon dioxide, then neon, helium, crypto, xenon and hydrogen. nitrogen, oxygen, argon, carbon dioxide, then neon, helium, crypto. They may ask you to arrange the composition in increasing or descending order. Okay. So, that is about the introduction to climatology, where we discuss about composition and this thing. Okay. And the next class we will be discussing the structure of atmosphere, winds, pressure belts, and then we will move to Indian geography and then environment. Okay. I hope you have enjoyed this class. So, keep supporting. Please do like, share the T1 academic classes, so it motivates us to come up with good content in near future. Thank you.